Welcome back, fellow mathematicians. Long time no talk. You're back with Miss Ledbetter, and it's time again for some more math. Today we're looking again at solving exponential equations, so still looking at exponents, but now we're actually putting it in terms of an equation. We actually get to solve and do some algebra. This is the good stuff. That's what we've been waiting for. All right, so you need to be making sure that you're following along in your interactive notebook. We're putting this on page 49 right after our laws of exponents that we just finished. Okay, so if you saw a problem like this, where it says 2 to the x is equal to 2 to the third, and you were asked to solve for x, what would you say? Duh, x equals 3, right? Stupid question. Well, what if you saw an equation that says 2 to the x equals 8? What would you do then? Again, stupid question, because we know that 8 is the same thing as 2 to the third power, so then therefore still x would be equal to 3. So basically, essentially, that is the point and purpose of what we are going to be doing, solving our exponential equations right now. Without going into logarithms, we'll do that after spring break. But if you are looking to solve for a variable in the exponent, they must have the same base. So whatever it's equal to, you would have to rewrite that number, that value, in terms of the same base as what the exponent is modifying. So we'd have to replace 8 with a base of 2, and we know that 8 is the same thing as 2 multiplied by itself 3 times, so 2 to the third power. Okay? So here's our first example. If we have 3 raised to the 2x exponent equal to 27, well, change the base. We know that 27 is the same thing as 3 to the third power. So then therefore that would tell us that 2x must be equal to 3 if we just ignore their bases and just make their exponents equal to each other. Well, if 2x equals 3, then therefore x equals 1.5, or 3 halves, 3 divided by 2. Not bad. Okay, so what if we had something like this, where we're multiplying 2 times 3 with the exponent of x is equal to 162? Well, the first thing that we have to do is we have to get that base with its exponent by itself. Whatever the exponent is modifying, we have to have that by itself. That means I have to get rid of that 2 first. In order to get rid of the 2, I have to divide. But anything I do on one side of the equal sign must also do on the other side. So I'm going to divide by 2. So now I have 3 to the x is equal to 81. Well, I know that 81 is the same thing as 3 times itself 4 times. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So 3 to the x is now equal to 3 to the fourth. So therefore x equals 4. Complicated yet? No, not really. All right, so let's try something like this. What if we have 9 times a 4 raised to the 2x? Again, same story. I have to get that base with exponent by itself first. So first thing I have to do, divide both sides by 9. Okay, so 288 divided by 9 is going to leave me with 32. So 4 to the 2x is equal to 32. Okay. Well, I need 32 to be in common with the 4, but if I did 4 times 4 is 16 times 4 is, or 4 times 4 is 16, 16 times 4 is 64, I'm going way too far. I can't make 4 become a 32. So then can I rewrite the base of 4 using a different base? So can I rewrite 4 to be anything other than 4? Well, that's the same thing as saying 2 times 2. So I could make the 4 become a 2 squared to the 2x. And then that's an x. Can I rewrite that 32 with a base of 2? Well, let's see. If I did 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So that would be 2 to the 5th power. So then now I have, over here on my left side of the equal sign, I have a power of a power, and that's what we learned in the last video. If I have 2 raised to the 2 times with the 2x exponent, that actually means that I have 2 to the 4x is equal to 2 to the 5th. Well, now if they have the same base, ignore the bases. So then that means that 4x equals 5. So then therefore x equals 5/4 or 1.25. Okay? So let's try another one. What if we have, what if we're multiplying a base with an exponent and also adding? Again, same thing. I have to get the exponent with the base by itself first. So order of operations, PEMDAS, whenever I'm solving the equation, I always go in the reverse order. So I have to get rid of whatever's being added or subtracted. So first thing I'm going to do is get rid of this plus 5. So if I get rid of a plus 5 there, that means I'm going to subtract 5 on the other side. So then I have 3 times 5 to the x minus 7 is equal to 375 after I subtract. Then divide both sides by 3. Dividing that by 3 gives me 5 to the x minus 7 is equal to 125. Well, I know 125 is the same thing as 5 to the third power. Because 5 times 5 is 25. 25 times 5 is 125. So then, ignoring their bases, that means that x minus 7 equals 3. So then, therefore, x is equal to 10. Okay? Slightly more complicated, still not terrible. The big important factor is that I have to have the same base. Once you have the same base for your exponents, then you just ignore the base, just solve the exponents. Make the exponents equal and solve it. So here's the problem. Your turn. You try. See what you can do on your own. So pause the video for a second. See if you can solve this. 7 times 4 with an x plus 2 exponent is equal to 1,792. See if you can figure it out on your own, and then we'll unpause the video and see if you get the same answer I got. Okay? So when you're solving it, first thing you're going to have to do is divide both sides by 7. And then you can actually change, when you have left over, 1792 divided by 7 is 256, which you can change to a base of 4. 4 to the 4th power is 256, so then therefore that tells you that x plus 2 must be equal to 4, so therefore final answer, x equals 2. And that is how you solve exponential equations. You will have a quiz tomorrow in class, so make sure that you understand. If you have any questions, I am available before or after school, and we'll see you next time. Thanks for listening.